we just used, we said that the maximum shear stress is equal to 1.2 times FH over L, right? But now what we are saying is taking the conservative approach. If we look over here, so the stress is basically, when we calculate the stress, we say that it is 1.414 times F over HL as compared to 1.2 times F over HL. So if we compare this, we are basically taking the estimate of the stress 1.17 times more than the one that we had. ठीक है जी? So now what we have here is, okay, we are going to take this conservative approach to analyze our fillet welds. ठीक है जी? So let's see, when we do that, we can also treat. जी, go ahead.
हमने जो कंपैरिजन की है 1.17 हमें क्या शो कर रहा है? कंपैरिजन से जो 1.17 निकला है, सर ये क्या शो कर रहा है?
It is just saying that you know, basically we were saying कि जो जो हमने एनालिटिकल मॉडल बनाया था ना, उसमें वो था 1.2 समथिंग F ओवर HL, ठीक है जी? But taking the conservative approach, we are not counting that as 1.2, but we are counting that as 1.4. So basically we are enhancing our stress by 1.17. ठीक है जी? तो ये 0.17 टाइम्स हम उससे ज्यादा ले रहे हैं. समझ आ रही है बात? ठीक है जी? So now let's say for example we have a parallel fillet weld. देखिए ये एक पैरेलल फिलेट वेल्ड है. ट्रांसवर्स की हमने बात की ना, ट्रांसवर्स विल बी द वन वेयर योर एफ इज परपेंडिकुलर टू द वेल्ड. अगर यहाँ पे हमारे पास वेल्ड होता, ठीक है जी, तो दैट वुड बी क्या, ट्रांसवर्स वेल्ड. ठीक है जी. लेकिन यहाँ पे पैरेलल फिलेट वेल्ड है, एंड द सेम इक्वेशन आल्सो अप्लाई फॉर अ सिंपलर केस ऑफ सिंपल शेयर लोडिंग इन फिलेट वेल्ड. यहाँ पे भी हमारे पास ये इस्तेमाल होगा, बिकॉज दिस इज योर एच. ठीक है जी. तो आई वुड से कि दिस इज आवर एच. ठीक है जी. दिस गिव्स यू अ बेटर व्यू. ठीक है जी. तो एच हमारा ये है, एंड दिस इज आवर एल. ठीक है जी. तो अगेन वी कैन यूज द सेम फार्मूला, जिस तरह एज वी डिस्कस्ड अर्लियर इन द सेकंड थर्ड स्लाइड, कि टाउ इज इक्वल टू 1.414 एफ ओवर एच एल. तो इससे हम कैलकुलेट कर सकते हैं अपना टाउ, विच इज द torsion, the shear stress on the welded joint. ठीक है. Now let's see, अगर इस तरह की बात है तो let's see, what we will do is there is another situation. For example, मतलब that was just straight on the on the on the welded joint जो था वहाँ पे, जो the load was passing through the same the welded joint. ठीक है जी. लेकिन जिस तरह in the bolts there where we discussed eccentric loading, so we can have that situation over here, that let's say that this is your welded joint. ठीक है जी. This is your welded joint basically, and your load is applied over here, right? So there is a the weldment and in the force that is applied, that is at not exactly applied uh, on the welded joint, but it is at some eccentricity, right? So again, uh, we can have the situation over here, which we just discussed in our bolted joints, that we will have two kinds of stresses over here. Now, let's say that this fillet weld loaded in torsion. Torsion means that we we have a twist in here. ठीक है जी? तो there are going to be two components of the shear, which is the primary shear, and that primary shear will be tau dash, which will be equal to V divided by A, okay, which is the shear force divided by A, and we will have another uh, component, which is the secondary shear, and that will be equal to TC by J, yeah, TR by J, ठीक है जी? So yeah, MR by J, because M and T, they are the same, force into force arm multiplied by R divided by J, ठीक है जी? Now, the thing is, how do we deal with such situations in welded joints is that A is the throat area of all the welds. ठीक है जी? All the welds mean we can have a weld over here, we can have a weld over here, we can rather have a weld over here. How do we combine them? How do we group them? ठीक है जी? So again, just like the bolted joints that we did, what we are going to do is we are going to take the same approach, that we will take the centroid of the welded group to to some point of interest, and then calculate the values of the required, जो हमें यहाँ पे required है, या the ones that we need over here. So for example, J is the second polar moment of area if we are dealing with torsion, ठीक है जी? Because that is used over here in torsion. So how do we find out this moment of area of Feldman group about a centroid of a group? So let's see that. What we are going to do is we are going to represent a welded joint.
हेलो
जी जी जी. Hello. Hello. Go ahead.
सर बोल्ट में जो हमने प्राइमरी शेयर लिया था उसमें हमने एरिया से डिवाइड नहीं किया था, हमने नंबर ऑफ बोल्ट से डिवाइड किया था, ये क्यों सर?
Okay. Because at that time you were just dealing with force. ठीक है जी? हाँ, यहाँ पे तो हम स्ट्रेस की बात कर रहे हैं. At that point we were just finding out the force, not stress.
ओके 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 सर.
ठीक है जी? यहाँ पे हम स्ट्रेस की बात कर रहे हैं. अच्छा जी. तो now let's say कि the rectangles represent the throat areas. For example, let's say हमारे पास ये दो weldments हैं, ठीक है जी? Let's say इस पे जरा ध्यान दीजिएगा थोड़ा सा, कि एक हमारे पास ये है, right? And then we have this one, ठीक है जी? अच्छा, let's say कि we have y axis, ठीक है जी? जो that are represented by this line, ठीक है जी? And we have x axis that is represented by this line, ठीक है जी? Let's say कि we have the the center of gravity of this one is lying over here, which is at G1. The center of gravity of this one is at G2. ठीक है जी? तो we know that the center of gravity of both of these is going to be somewhere over here, which is the centroid. Centroid is going to be somewhere over here on this line, and let's say that it is somewhere over here at this location, which we call G. ठीक है जी? And let us say that the distance of in the y direction is y bar, ठीक है जी, and that in the x direction is x bar, ठीक है जी। तो the location of the centroid is at x bar and y bar, ठीक है जी। Let's say that this weldment has a thickness T1, ठीक है जी, and it has this length D. Similarly, let's say that the thickness of this is T2 and it has um, length B, ठीक है जी। अच्छा, and let's say that this centroid over here is located at x1, ठीक है जी, and since we have 0 y1, so well we don't have y1 actually, that is y1 is equal to 0. Over here, let's say that this is located at G2 is located at x2 and y2, ठीक है जी, x2 and y2. So all parameters are described over here, ठीक है जी। कोई चीज रह गई है, कोई क्वेश्चन? Any question? अच्छा जी, now let's see. Again, we are going to use the same equation. Okay, x bar is equal to a1 x1 plus a2 x2 divided by a. Similarly, y bar is equal to a1 y1 plus a2 y2 divided by a. Now, as far as finding the जो rectangles हैं हमारे पास, they represent that t is equal to 0.707 times h, which is the minimum throat height, ठीक है जी। thickness जो है, अभी हमने पिछले slide में we said that t is equal to 0.707 times h, ठीक है जी। अच्छा, लेकिन फिलहाल if you want to calculate a, that will be the sum of the areas, which is a1 plus a2, and we can find out a1, what is a1? t1 times d, ठीक है जी। This dimensions multiplied by this dimension, so that is t1 times d plus t2 times b, ठीक है जी, which is the area of a2, ठीक है जी। तो I can also go ahead and find ix. Ix क्या होगा? We know that it is bh cube by 12. So what is b for the first one? That is t1, ठीक है जी, time d cube divided by 12. For the second one, it is we have x dimension, इसका क्या है? जो जो हमारा दूसरा डायमेंशन है फॉर दिस सेम जो फर्स्ट वेल्डमेंट है, आई वाई इसका क्या होगा? इट विल बी दैट वाज बी एच क्यूब, नाउ इट विल बी एच बी क्यूब बाय 12. तो दैट इज डी टाइम्स टी वन क्यूब बाय 12, ये बन जाएगा। एंड फ्रॉम दिस वी कैन फाइंड आउट आवर सेकंड area, ठीक है जी, which is jg1, and it will be the sum of these two. Solid mechanics में आप लोगों ने पढ़ा होगा कि it will be ix plus iy. तो ix plus iy अगर हम करें तो we can find out कि हमारा jg1 जो है that will be t1 d cube over 12 plus dt1 cube over 12, ठीक है जी। तो इसी तरह हमारा jg2 is equal to सिमिलरली, ठीक है जी, इसके लिए हमारे पास jg2 जो होगा that will be equal to jg2 will be equal to bt2 cube over 12 plus t2b cube over 12, right? So now we have these j's. We can combine jg1 and jg2 with this theorem, and our j will be equal to, if we find out r1, because what will be r1? Okay, from this geometry, if you look over here, so we have this triangle, right? Now it's a right angle triangle, so the square of this plus the square of this is equal to the square of this. ठीक है जी. तो और R1 will be equal to this dimension. What is this dimension? This is basically x bar, ठीक है जी, minus x1. X bar, okay, this is whole is x bar, and if I remove this from it, so that will become this dimension will become x bar minus x1. ठीक है जी. So I have this dimension now, x the square of x1 x bar minus x1 plus y uh, bar square plus y bar square is equal to r1 square. ठीक है जी. So I have this equation. ठीक है जी. So from this I can calculate r1. Similarly, I can also calculate my R2. ठीक है जी. Because यहाँ पे भी I have another triangle over here, which is this one, right? So I can calculate this R1 and R2 from here, and I'll find my J. ठीक है जी. Once I find X bar, Y bar, R1, R2, and J, now I am able to move forward and do my calculations. ठीक है जी. अच्छा, लेकिन there is one more thing. Let's say I represent this weldment and this weldment by something else. Let's say I represent them by a line. ठीक है जी. Instead of putting the triangle, I just say that this is, let me put it in red. ठीक है जी. Let's say that I just say कि ये जो weldment, ठीक है जी, and I have another weldment over here which I represent by this. Now what happened to T1 and T2? Can someone answer me?
हाफ हो जाएगा.
Half नहीं, बिल्कुल ये है ही नहीं. बस I am just representing the first weldment by this and the second weldment by this. बस that's it. So what I am doing here is, देखिए, if you compare these two, देखिए, if I say that T1 d cube, so T1 is a very small dimension. Similarly, T2 is a very small dimension. If I cube this B cube अगर मैं ले लूं, so T2 is also a very small dimension as compared to that. So for now, I just say that T1 is equal to 1 and T2 is equal to 1. मतलब we don't have them right now. So my what will be my BH cube over here? It will be just D cube by 12. Right? So what I am doing here is, to make it very easy, what we have done here is, if you look over here, so usually what we would do is this T cube term, we can just neglect it, leaving JG1 and JG2 linear in the weld width, right? So we can normalize, what we did was we just divided it by the thickness, and we can normalize it as a line with a unit thickness T. So जैसे अभी हमने कहा line, we'll just represent it with lines. ठीक है जी. Now if we have lines, so I'm not going to call this now J1 and J2, JG1 and JG2, बल्कि I'll call it just J. ठीक है जी. So now what is my J? My J is equal to my J is equal to JU rather, right? The one that I just calculated. Since I know that the thickness which I excluded in JU is equal to 0.707 times H. So if I know the thickness of the weldment, if I know h, I can calculate the thickness of the weldment, which will be t equal to 0.707 times h. So now I can calculate my actual j when I multiply this ju by t. And if I multiply ju by t, t is 0.707 times h, so that is 0.707 times h times ju. Okay? So it makes it easier for me, and you don't have to calculate this, but there is just a table. Okay? So for example, you look at this table. What does this table say? This table say that if you have a geometry like this, we know what the throat area is. A is equal to 0.707 times HD. The location of G is x bar y bar आपको देता है this table. It also gives you the value of Ju, and if you multiply this value of Ju by 0.707 times of H, it is going to give you J. ठीक है जी. Similarly, if the geometry looks like this, then A is equal to 1.414 times HD. Why is it 1.414 times HD? Can someone comment on this?
Sir, conservative approach.
No. It is because it is double of this. This is 707, this is one weldment multiplied by 2. So that makes it 1.414 times. ठीक है जी. इसी तरह x bar is b by 2. ठीक है जी. x bar आपका कहाँ पे आ गया? Half of this and half of that because of symmetry. So b by 2 and d by 2. But they are already calculated for you. Don't need to think about it. Just come to this table and have a look at the geometry. You will compare your geometry with it. It will give you area. It will also give you x bar y bar, and it will give you the value of Ju. You can multiply this value of Ju by 0.707 times of h, and that will give you the actual J. So there are different cases in here to which you can compare whatever problem you have. You can compare that, and from this table 9-1 you can find the values of all these. ठीक है जी?
सर
जी
सर
जनाब.
11 बज चुके हैं, हमारी क्लास है एफएम की, फ्लूइड मैकेनिक्स की.
अच्छा, तो हम थोड़ा सा
यस
इसमें
सर.
मैं थोड़ा सा ये एक प्रॉब्लम इसके साथ एसोसिएटेड है ना, तो इसको थोड़ा सा डिस्कस कर लेते हैं. ठीक है जी.
यस सर, मैं सर को मैसेज कर देता हूँ.
उसको मैसेज
5
करें
मिनट.
जरा, 5-10 मिनट हमें दे दे बस. ठीक है,
ओके.
देन वी विल जस्ट क्विट. ठीक है जी. अच्छा, तो if you look over here, it says that a 50 kilonewton load is transferred from a welded fitting into 200 millimeter steel channel, illustrated in figure 9-14. Estimate the maximum stress in the weldment. ठीक है जी. तो ये हमारे पास we have a 50 kilonewton load. ठीक है जी. ये फिटिंग है. जिस तरह ट्रैक्टर के साथ ट्राली आप लोगों ने देखी होगी ना, इट्स ऑलमोस्ट जॉइंट लाइक दिस. ठीक है जी. तो यहाँ पे वेल्डमेंट है हमारी, विच इज वेयर h is 6. ठीक है जी. एंड इट इज अ फिलेट वेल्ड्स है हमारे पास. ठीक है जी. And the dimensions are given to you कि this is 200 millimeter, this is 6. ठीक है जी. And 6. Similarly, the load that is applied is 50 kilonewton over here, and the distance from here to here is 100, and that from here to here is 56. ठीक है जी. It is welded on both sides with 6. h इज इक्वल 6, और ये जो डिस्टेंस है यहाँ से, मतलब ये जो स्ट्रक्चर है यहाँ से यहाँ तक, दैट इज 190 millimeters. ठीक है जी. नाउ if we look at this and let's say draw the free body diagram for this, so it is going to look something like this. देखिए अगर दो sides हैं, if we have two sides 1 and 2 and 50 kilonewton load is applied, so it will be 50 divided by 2, so that will become 25, right? So the load is 25 kilonewton, right? And then we can looking at this figure, we can figure out the values of these 100. ठीक है जी. and then 110.4 from here to here this point. ठीक है जी. Similarly, ये हमारे पास, this is 190, so it's going to be 95 on one side and 95 on the other side, and we already have this 56. ठीक है जी. So we can figure out these values. ठीक है जी. अच्छा, now what do we need to do? What will be the next step? We are going to look at this structure, yeah, the weldment जो हमारे पास है, and compare it to the table, the table that we just talked about. ठीक है जी. So let's go ahead and look at the table. ठीक है जी. So if we look at the table, so what do we see? कि उस टेबल में अगर हम जाएं, ठीक है जी, तो चलें हम जरा देखते हैं इस टेबल को. Does it look like this? Does it look like this? No. ठीक है जी. Does it look like this? No. Does it look like this? No. ठीक है जी. So move to the next page. How about this one? Number 4.
Yes, number 4 is that.
तो नंबर 4, तो इसका मतलब ये है कि now we have area. We can calculate the area using this formula. We can find out our x bar and y bar, and we can find our ju, and we multiply this ju by 707 times 0.707 times h, which is 6. So 0.707 times 6 times ju, that will become our मतलब j मिल जाएगा हमें. We will get j, right? So let's see. Doing that, first of all, we can find out the area using the formula given over there. अच्छा जी, as far as the primary shear is concerned, tau dash, which is equal to V by A. So now let's find out x bar from the table again, y bar and x bar, and we can find out our RA, RB, RC, and RD from here. ठीक है जी. Once we find these, we can find out और J. जैसे अभी मैंने कहा कि what, how do we find J? How do we find J? You multiply that
0.07
times
h multiplied by j.
तो ये हमारा J निकल आया. Moment F times L. ठीक है जी. We know what F times L is. If we go back, we can say कि हमारा जो F times L क्या होगा. This is your F, which is 25, and let's say L कितना होगा. L कितना होगा.
110.4.
110.4. ठीक है जी. So we will multiply that by 110.4. Now we can find out our tau dash A, tau double dash A, tau double dash B, tau double dash C, and tau double dash D. So where is the maximum stress? मतलब the stress component ये है ना 41. लेकिन हमने what do we need to do? We need to sum these two. Tau dash, ठीक है जी, plus tau double dash. ठीक है जी, at A and B and C and D. ठीक है जी. तो इन सब को हम ऐड करेंगे. ठीक है जी. एंड वी कैन फाइंड आउट कि हमारे पास जो मैक्सिमम स्ट्रेस है, अगर आप देखें तो द मैक्सिमम स्ट्रेस कम्स आउट टू बी at C and D, which is 43.9 MPa. ठीक है जी. तो 43.9 MPa is the highly stressed places in the joint. ठीक है जी. Similarly, अच्छा, अब यहाँ पे थोड़ा सा हम एक चीज और देखते हैं. The same kind of thing we are going to follow for fillet welds loaded in bending. Bending में क्या होगा? Bending में MC over I. ठीक है जी. तो जैसे वहां पे TC by J था, तो हमारा एक होगा सिग्मा डैश. ठीक है जी. और दूसरा जो कंपोनेंट होगा, that will be sigma double dash if the load is applied somewhere else, not exactly at the weldment. अगर यहाँ पे होता तो we would not have any moment. लेकिन यहाँ पे हमारे पास जो सिग्मा डबल डैश है वो इसके बराबर होगा। ठीक है जी। तो इसके लिए भी फॉलोइंग द सेम प्रोसीजर, योर सिग्मा योर टाउ डैश इज v बाई a, लेकिन टाउ डबल डैश जो है दैट इज mc ओवर i। अच्छा, इस तरह वी आर गोइंग टू फाइंड आउट iu यूजिंग अ टेबल, द सेम सेम जो है प्रोसीजर फॉलो करते हुए वी आर गोइंग टू फाइंड आउट आवर iu। ठीक है जी। सो यू विल कंपेयर योर वेल्डमेंट विद दिस, you have area, the x bar, y bar, and iu. You multiply this iu by 0.707 times of h, and you will get your I. ठीक है जी। So once you get your I, you can calculate your sigma dash and sigma double dash. ठीक है जी। The primary component and the primary component and the secondary component। ठीक है जी। तो ये आप लोग फाइंड कर लेंगे। तो with that you can have your calculation of the the stress due to bending, summing sigma dash and sigma double dash। I think this should be enough for today। हाँ, ठीक है जी। Any question? Any
Okay, sir.